Okay? So let's take a look at what we got here. Okay, let's zoom back out. And so our book here has us starting out with some basic multiplying and dividing of rational expressions. Okay? Right, in a very basic sense, when you multiply two fractions together, both of these things are rational expressions. Okay? So like 4/5 is a rational expression, just like some of these things are up here, also called rational expressions. Okay? Obviously, these are more complicated rational expressions like we saw in the warm-up here. But 4/5 is also a rational expression. Okay? So we want to know how do we multiply 4/5 times 5/6, right? So what do we do here? We multiply the 4 by what? 5, right? 4 and the 5, they multiply together. So we're going to multiply the 4 by the 5. What's that? Well, we're going to get to that. We're going to get to that. We'll get to that here. Okay? So we multiply the 4 by the 5 to find the numerator. Okay, I think that's supposed to go there, of the product. And then we're going to multiply this 5 in the denominator by what? 6. Yes. To find the denominator. Yes. Sure. Okay. So 4 times 5 gives us what? 20. And then 5 times 6 is 30. Okay. And then to simplify, you factor the numerator and denominator. Okay. So they say to factor it, which means to like break it up into its pieces. So for example, 20 is like 2 times 10. 30 is 3 times 10. Okay. But then they break those 10s down even further. They send it, okay, it's like 2, and then 10 is 2 times 5. And then here it's going to be 3 times 2 times 5. Okay? So they break them down as far as you possibly can. The prime power factorization. Okay. What's that?
Never done that?
Never done the prime power factorization? Yeah. So, and again, is it necessary? Not really. You could have seen here that the 10s were going to cancel, but you know, this is one way to do it, and it kind of does lend itself to what we're going to be doing in a second here too. So, but the idea is you want to factor here, see things that are in common factors of both of these to then be able to cancel out. So if you look here, they did that for us right here. 4/5 times 5/6, 4/5 times 5/6 gives us the 20/30. They factored the 20 to be 2 times 2 times 5, and the 30 is 2 times 3 times 5. And it says cancel common factors. So what factors do we have in common here, folks? What can we cancel? 2's and the 5's. And so we're left with 2 and 3, 2/3. Okay, it's 2/3. Which again, you could probably see from letter B. Since you've got 20/30, you could just divide the top and bottom by 10, right, and get 2/3 that way. Notice when we canceled out a pair of 2's and a pair of 5's, which would be like canceling out a 10, right? Because a 2 and a 5 multiplied together is 10, right? So that's one way to kind of think about that. All right. So then, let's take this and expand on these steps. Then, so take the multiplying rational numbers, those steps that we use to multiply rational numbers, and expand it to multiply the rational expression right here. Okay. So when we multiply here, okay, we multiply across the top. So it's going to be 3 times x plus 1, I'm going to put the 3 in front, over, and then I'm going to put the 2 in front here, and then we have the x minus 1, and the x plus 1. Okay, just like that. Again, I multiplied across the top, and again, I put the 3 out front. You can put it behind it if you want. And multiply across the bottom. The 2 came out front, and the x minus 1, the x plus 1. Now, what can we do? Is there something in the numerator and denominator that we can cancel out? Are there any common factors? Yeah, the x plus 1, right? So cancel those out. And so this is now equal to 3/2 times x minus 1. Are there any more common factors to cancel out here? No, we are done. Okay, that's all we need to do. That's it. Okay? So that's all. All right? If we were going to divide, we would follow the same kind of steps. Okay, when we divide, we're going to change, except we're just going to change division to multiplication, and then multiply by the reciprocal. Okay? So if we look here at the next page, letter A, example 1, letter A, it says find the products and any excluded values. Okay? So if we look here at letter A, we're going to multiply these two expressions right here. 3x squared over x squared minus 2x minus 8 times 2x squared minus 6x minus 20 all over x squared minus 3x minus 10. So guess what? We're going to get a lot of practice with factoring quadratics. Yeah. Okay. So the numerator here, the 3x squared, doesn't factor any further. Okay. But, so you can see it just stays 3x squared. This 2x squared minus 6x minus 20, you can see that all these numbers are even, the 2, the 6, and the 20. So they factored the 2 out, and then they factored the remaining quadratic. So it's 2x plus 2, x minus 5. This quadratic here, they factored to be x plus 2 times x minus 4. And this quadratic here, they factored to be x plus 2 times x minus 5. Okay? Then they multiplied everything together. So 2 times the 3x squared gave us 6x squared. And then the x plus 2 and the x minus 5. And then there was the x plus 2, the x minus 4. And then another x plus 2, and then x minus 5.
Didn't you just simplify the one on the right to 2?
So, like you're saying right here, so yeah, we could have at this point kind of like cross-simplified as like David described it earlier, or even simplified right here as well, and the x minus 5. Yeah. So you don't need to wait till it's all one big product to simplify. If you, because again, it also saves some steps too, right? Because it's a lot to write all this. We could have canceled right here, and then multiplied things together. They chose to wait though and do it right here instead. Make it all one big product here and here, and then they started canceling, leaving behind still though what you would expect, the 6x squared over the x plus 2 times x minus 4. Notice again, they don't multiply out those denominators. They leave it that way. So you don't need to multiply it out either. Okay? Now, we found the product, but it also says find any excluded values. Remember, we don't want to divide by 0, right? We talked about this before. That's where we had those vertical asymptotes or holes. Here we can see that this expression, okay, if we were to graph this right here, okay, we would have holes at -2 because these two things cancel out. And we would also have a hole at 5 because those two things cancel out, the positive 5 because those cancel out, okay? But still, we want to exclude any holes or any vertical asymptotes. So what values, according to our denominators here, or even here you could look, right? What values must we exclude? What x values will give us trouble? What will make us divide by 0? So what's that? -2, 5, and 4. Yeah, there's 3 values here. -2, if I plug it in here, will make this 0, and so the whole thing will be 0. If I put 4 in here, that'll make that 0, and so the whole thing will be 0. This is the same, so it's -2 again. And then positive 5 will make the denominator 0. So we have to exclude the denominator. We have to exclude -2, 4, and the -2 and the 5. You don't need to list -2 twice. Just listing it once is fine. So excluded values are -2, 4, and 5. So you can see that's your other answers there. So we have to figure out what values we don't want to include so that we were divided by 0, and then there's our product. Okay, so that's kind of our two answers there.
Why wouldn't you just find the excluded values of it when it's all the way simplified? Right at the end, when you wouldn't have to include the 5.
I see what you're saying. It's because the original problem that we were trying to simplify was this. Okay? And so technically these two things are not exactly equal. We're saying they're equal, right? There's that equal sign, but they're not exactly equal unless we exclude these x values. If we exclude these x values, then these two things are equal everywhere else. That's why we have to exclude those x values, Greg. And for anyone else that was curious. Okay? So look at letter B here. Okay? Letter B, they have all these blanks to fill in. I'm not going to, well, I don't know if I want to fill in these blanks. Okay. I'll hold, I guess we'll try filling in the blanks here. Maybe it won't be too bad. Okay, so we're going to multiply. All right? So we're going to multiply this by this. Okay? And so there's our problem. Okay? You can see here, the x squared minus 8x, what can we factor out from there? There's a GCF of x. So in this little box here, we'll put an x. We pulled an x out, leaving behind an x and a -8, right? Okay? Yeah. Okay? What about here? What can we factor out from the 7x plus 35? A 7, right? What's going to be left over, though? X plus, and then a 5. There you go. Okay? Here, there was already a 14 factored out, so we can leave that 14 factored out, but then this quadratic also factors. What are two numbers that multiply to 15 but add to make 8? 5 and 3. So we have the x plus 5 there, so this is going to be the x plus 3 one then. Okay? Again, they chose to multiply everything together first, and then they're going to cancel out. I say let's just skip this step, and let's just cancel out from this step right here. Okay? What can we cancel out here, folks? Okay, they both have an x plus 5. One's an x plus 5 in the denominator, one's in the numerator, so yep, we can cancel out the x plus 5. Does anything else cancel? Can this x plus 8 cancel this x minus 8? Nope. Yeah, no, they're not exactly the same. Does the x plus 3 cancel with anything? No. Does the x cancel with anything? Well, there's no other x just by itself, though. They all have other things that are added to them, like x plus 3, x plus 8. So the x can't cancel. It's just an x by itself. What about the 7? Can the 7 cancel with anything?
The 14?
The 14, yeah. So 7 is 1, 14 will be a 2. Divide both those by 7. The reason why we can divide that 7 is because that 7 is by itself. It's not being added or subtracted to anything else. Likewise, the 14. It's not being added or subtracted to anything else. This 2 cannot cancel with like this 8 here. Yes, they're both even. Yes, they're both divisible by 2. But the 8 is attached to that x minus 8. This 14, which then became a 2, is by itself. It's not attached to anything else, so it can only cancel that 7 there. If it was 2x, if this was like 2x here, then the 2's could cancel. Because again, that 2 would be kind of like by itself. It would be multiplied.
Can you multiply the x plus 8 by negative 1 on the denominator on the second part, and then
Cancel it out with this?
Yeah.
Let me get to that in 1 second. I like that you brought that up.
I forget whether that's a rule or not.
So that is a thing,
Okay.
but it doesn't help us here, okay? So David, probably from past experience, has seen that sometimes these x plus 8s, you can multiply a negative 1, or you can like kind of factor out a negative 1, I guess is what you could maybe call it. And so if you take a negative 1 out of this, so let me just show you here.
Oh, that doesn't help you because then you have a negative x.
Exactly, it'll also be negative x, yeah. So David's like thinking really creatively here, because if we take a negative 1 out, we're going to be left with negative x minus 8. And that's really close. They're both minus 8, but then this one's negative x and that's a positive x. So yeah, unfortunately, that does not help. In order to be able to do the factoring out of negative x, David, they need to be exact opposites of each other. So where this is positive x plus positive 8, this should be negative x minus 8 in order to be exact opposites. And we may run across something like that. I don't know. I'll keep my eyes out for that, though. Okay? But anyway, here is our final answer. That's as far as we can simplify. Oh, sorry. Off the screen. There we go. Okay? So that's our answer, but what are the excluded values? Well, we got to go back up to kind of like our factored version up here. Okay? So look at our denominators. What are some x values that would give us 0 in the denominator? Negative 8. What else? Negative 5. Yes, even though we canceled it out, we still want to count that. So yeah, we're going to exclude x equals negative 8. We're going to exclude x equals negative 5. One more. X equals negative 3. So we're going to exclude x equals negative 3, x equals negative 5, and x equals negative 8. Because those will all make our denominator 0, and therefore the thing will be undefined. Okay? So we have to exclude those. Even though here, that x plus 5 is gone, in the original problem it was there, and so we have to include that too. Even though it cancels out, okay, we still have to exclude it. Otherwise, this is not considered to be equal to this. Okay? Because this one, if you plug in 0 here, if you plug in negative 5 here, you get 0 over 0. If you plug in negative 5 here, it's no problem. You'll get a number, which is fine. 0 over 0 is not the same thing as a number, so again, we have to be careful there. All right, I'm going to call on some people here. We'll try and get this some more practice. So let's think of this next one here, number 2. Okay, we'll try some here together. All right, let me call on some folks. See how we do. All right, so David, Help us out here, okay?
Alright, I'm gonna factor the top first.
All right, back at the top. What is x squared minus 9 factor to be?
The difference of squares.
Yes, it is.
With x plus 3 and x minus 3.
Very good, sir.
Then I'm gonna factor the bottom.
Okay.
And make it x minus 8, x plus 8.
X minus 8 and x.
Oh, I'm sorry, x plus 3.
There you go. Okay, very good. Uh-huh.
And I'm gonna factor the second denominator.
Okay.
And take out a x.
All right, so we're going to use GCF here, okay, and so take out, I was going to say 2x would be even better. Yep, okay, and what's left then?
And you got x minus 9.
Okay, good. All right, so let's just pause real quick so we can make sure everyone appreciates what happened here, okay? So again, David saw a quadratic here, specifically a difference of squares, okay? You can also think of this as just, we need two numbers that multiply to make negative 9, but add to make, well, 0. There's no middle term. So two numbers that multiply to make negative 9, add to make 0. That's positive 3 and negative 3. Okay, two numbers that multiply negative 24, add to make negative 5, negative 8 and 3. X minus 8, nothing factors out of that. And then here we have a GCF of 2x that we factor out and leaving behind an x minus 9. Okay, great. Thank you, David. Now, what can we do here?
Cancel.
Cancel. What cancels?
Well, you got x minus 8.
Okay, and the numerator and denominator there. Good.
And you got
X
x plus 3.
plus 3. Okay, is that all?
That I see.
Yes. Sorry, sometimes I realize that as math teachers, we end and we don't give you an opportunity to make sure that you think you should end too. So that's why I like to ask that question.
Yes.
I know it can make students uncomfortable because they're like, because they think as soon as the teacher asks a question, they're like, wait a minute, maybe I did something wrong. Nope, you're right though. You're right. Okay, good job. Way to stand your ground. Okay, so there's our answer. That's as far as we can go, right? There's nothing more in the numerator that cancels the denominator, so we're done. And now I'm just going to list the excluded values. So I'm going to say exclude. Okay, just to kind of make it easier, we're going to exclude. Now, what x values do we need to exclude? Again, look back to your original denominators. What x values here would give us trouble?
8 and negative 3.
X equals 8. X equals negative 3 from that first denominator. What about the second denominator?
Nothing cancels out.
Okay, but still, but what x values would still give us troubles there? What x values would still make our denominator 0? Like, for example, what here?
Yeah, 9.
9. So we have to exclude that 9 still. And even though it didn't cancel out, so if it does cancel out, if it doesn't cancel out, it doesn't matter. If it's in the denominator at some point, we have to exclude that value. What about this x value right here?
That's fine.
What number can I put in for this x that would make my denominator 0?
0.
Yeah. We also have to exclude the x value of 0 as well, because the 0 into that x would make it 0. Okay? Again, we don't want to divide by 0. Okay? And again, going back to talking about graphing these things, right? We know that, for example, if we were to graph this original function here, the x plus 3, we'd have a hole at the negative 3. We'd have a hole at the positive 8, x equals 8. At 0 and at 9, though, since those didn't cancel, those would be what? If they're not holes, they are what? Vertical asymptotes. So at 0 and at 9, we'd have vertical asymptotes. Okay. All right, let's try one more here. Number 3. Pick somebody else. Thank you, David. All right, Stephanie, number 3. Okay, this one actually doesn't look too bad. Okay, I don't know why they put this one as the second one. Normally they should put the harder one second and the easier one first. But anyway, what do you say here, Stephanie? So, can we factor the numerator of this? Nope. How about this? Nope. How about this? Okay, what can we factor out of that? 3. And if we factor 3 out, what's left?
X minus 9.
Yeah? Yeah? That's right. And then x plus 1 again doesn't factor. Okay, Stephanie, does anything cancel?
X minus 9.
The x minus 9s. Very good. And so we're going to have, what's left in the numerator?
3x.
3x over? Yeah. Good job. That's it. Okay. Exclude.
9.
X equals 9. What else? There's one more. What other x value will make our denominator 0 here? Again, we canceled the x minus 9s out, but there's something else here in the denominator.
X
not positive 1,
Minus.
x equals negative 1, yeah. So we got to exclude those two, okay? Whether it cancels out from the denominator or whether it stays in the denominator, we have to exclude both those kind of numbers. Because again, from the original problem, here's why we do this. And I know it's like a very like idiosyncratic, it seems almost like too specific why we got to be so precise, but you know, it's math. This, we're saying this is equal to this. But this and this are not exactly the same when x is 9 or when x is negative 1. Up here, if you plug 9 in for x, you're going to get 0 over 0. Here, if you plug 9 in for x, you get 27 over 10. No problem. 27 over 10 is 2.7. 0 over 0, different, right? It's like indeterminate form. Same thing here. If you plug in negative 1 up here, you're going to get 0 over 0. If you plug in negative 1 down here, you're going to get negative 3 over 0. So still undefined. But I guess we still want to exclude the negative 1 there, just because we don't want to divide by 0 as well. Okay, we don't want to divide by 0. So that's that. All right. Questions on multiplying. Okay, we're going to do one division problem then, and because if you can do multiplication, you can do division. I mean, really, because we're just going to change any division problem to multiplication. So let's do that here real quick. Skip over to page 442. Let's turn the page there. 442, and we're not even going to bother going through one of the the practice problems. We'll just do one of these here together. Let's look at number 4. Okay. Patrick, do you remember? Dividing by a fraction is the same thing as multiplying by what?
Yes.
What do we do? What do we do here in this one, number 4? We had 1/2 divided by 3/4, and we changed it to 1/2 times. Yes, the reciprocal, exactly right. So, Patrick, instead of taking x plus 11 over 4x divided by 2x plus 6 over x squared plus 2x minus 3, I'm going to write x plus 11 over 4x times, and then what am I going to multiply by?
X squared plus 2x minus 3 over 2x plus 6.
Beautiful. There it is. That's all you got to do. Now it's all the same thing. It's the exact same thing we did before at this point. Okay, one little step. One little step is all it takes. Okay? So nice. So much nicer than adding and subtracting. Okay, so Amanda, help us out here. Okay? Can we factor that x plus 11? Nope. How about the 4x? Nope. How about this thing? Yeah. What two numbers multiply to negative 3 but add to positive? Plus 3 minus 1. Good. What about from the denominator here?
You could take a 2 out.
Yep, take out a 2, leaving behind what?
X plus 3.
X plus 3. Okay, so again, I'll pause here real quick because I feel like I'm going a little too fast and I'm also off the screen. There we go. Okay, so again, all Anna did for us here, after Patrick helped us out with flipping this thing, Amanda just helped us out. We factored everything. Again, just breaking it down so we can try and factor and cancel. That's our goal, is try and cancel stuff out. Okay. So, now we've got that, Amanda, does anything cancel? The x plus 3's cancel. Okay. Anything else?
No.
Yeah, sadly no. Okay, so we'll just multiply across the top here. X plus 11, times x minus 1. Over, whoops, I'm off the screen. There we go. 4x times 2, what's that going to be? 8x. Very good. Okay. Do I have to multiply the x plus 11 times x minus 1? Nope. You stop right there. Okay, and the excluded values, or sorry, not excluded, I'll just say exclude, okay, exclude. What x values here do we need to exclude? And I'll open this to anybody. What x values do we need to exclude here, folks? What x values, if we put them into our denominator, is going to give us trouble? Negative 11? That's in the numerator, so it's okay. Well, let's look at our denominator, though. So how about right here, Josh? What about this denominator right here? What number, if I put x in, what number in for x will I get 0 in my denominator here? Nope, because it's 4 times x. What x can I put in here? Anybody? 0, 0, 0. Because 0 times 4 would give us 0 in the denominator here. Okay. Josh, what about here? What about this one? X plus 3. What x value can I put in here? When I add 3 to it, will give me 0. Negative 3. X equals negative 3. That's right. That's the other one. Okay, negative 3. And so we got to exclude those two numbers. Okay. Alrighty. Questions on any of that? Alright, so that's it. I'm going to get you guys started on your assignment. Okay, please use this time to get started on your assignments. Alright, please use this time that I'm giving you in class to get started on this assignment. Okay. Do not dilly-dally, because I know it's very easy to do that. Okay, so here's what I would like y'all to try. Alright, I'm going to have you do 3 through 13, the odds on page 446. Page 446, starting on page 446, I'm saying. Page 446, yeah, 3 through 13, the odds. And more, and 14 and 15 as well. Okay. Yes, that'll do. Okay, so 3 to 13 odds and 14 to 15. Please use this time to get this done, okay? Get it done so you don't have to worry about any homework tonight or tomorrow. I'm here to help. Okay, that 14 and 15, that is